So as a third topic of today's lecture, I'm gonna have a discussion on stress under general loading in brief manner. So until now, we considered really simple loading cases. Here, of course, we can think about how to apply this loading. Like you can apply this loading at the point, or you can apply this loading widely over the entire surface. But without considering these details, we simplify the problem and just assume that stress would be almost uniform, this yellow cross section. However, in realistic problem, we have to consider quite complex continuum potato problem. I typically call this as continuum potato, and typically continuum potato is subjective to quite random and complex loading, F1, F2, F3, or it can be some displacement boundary and etc. Okay, now if you take out some imaginary plane out of this containing potato and try to focus on point P and point Q, how you can define like a stress. Of course, stress over the entire surface is not uniform. So depending on the position you take, you're gonna have different stress value. And how do you define stress at this infinitesimal plane? It's quite simple. You obtain the force, infinitesimal force acting on this P point, infinitesimal force acting on this Q point, including this yellow zone. Now, if you take the limiting value of this infinitesimal area goes to 0, infinitesimal area goes to 0, and of course you have to adjust this infinitesimal force in terms of force acting on this infinitesimal area, yellow area, then what you can realize here is you can define stress field as a function of xyz, the location of this continuum potato. Okay, so typically if you take an infinitesimal volume from the continuum potato, you're gonna have like a 9 component of stress, sigma x, sigma y, sigma z, and tau xz, tau xy, tau yx, tau yz, tau zy, and tau zx. Okay, so you can see that tau zx means the shear stress defined on the plane orthogonal to z-axis along x direction. Tau zy is the shear stress defined on plane orthogonal to z and along the y direction. Okay, so this is our textbook's notation. If you look at different textbook, you're gonna have a switching of z and y position and z and x position here. But if you're gonna read our textbook, this is what you're gonna get. And regarding the force acting on this infinitesimal volume, you have to multiply the area. Okay, so please do not confuse about the force acting on the infinitesimal volume and stress defined on specific point. Okay, so when you obtain the force, you have to multiply the area so that it has correct dimensions. Okay, so you can see that there is like 9 components, but actually out of 9 components, one cannot say that we have 9 independent variable, because if you look at the side view, what you're going to realize is that you can have tau yx and tau xy component here, and tau yx component here, tau xy component here. For the first balance, tau yx here, they should be same magnitude in opposite direction. And for the moment balance, you should see that tau yx and tau xy should be same value. Okay, so please remember that, like when you have this continuum potato and infinitesimal cube, you're gonna have same upper and lower value in opposite direction. And even though you consider different plane, like if you consider this plane, and if you consider this plane, you're gonna have the same shear stress due to the moment equilibrium. Okay, so there exists 6 independent stress components, and this is something you have to also remember when doing stress analysis. Okay, so you don't need to worry about obtaining 9 components. There are actually 6 independent components for stress on infinitesimal volume. Okay, so please have a please remember this.